This is a stool printed from NEWSand. We are comparing this with the earlier material that we printed with recycled glass. It's demolition glass that we ground down to like a sand-like particle and we printed it.
We know that we can print concrete here in Singapore. We can control the material quality, we can scale up, we can print a big object, big wall, big column. But the next phase is really about structural application. How can we make use of concrete printing in the public space? Some architects, they really want to have this sharp corner. Maybe in the future, there's also something we need to look at it.
That's a good idea. In future, we are also looking into 3D printing for high-rise construction.
I don't think any other country is starting concrete printing structure on high-rise building other than Singapore. HDB, they are the largest social housing developer in Singapore. They are focusing on construction. You can build your house and build on top of it. And you can build this unit off-site in the factory, and you can just move this unit on-site and hoist it up and do the assembly. We are an engineering consultancy company, specifically focused on digitizing and automating our construction industry. We provide high-end engineering consultancy services to building bridges, tunnels, infrastructure, water, port development. This is one of the bridges we are developing here in Singapore. It's also a small pedestrian bridge spanning around 15 meters. So nowadays we are talking about smart geometry. We can use this new technology that can use less material and then it can be cost-effective. If the displacement is over 1 centimeter, that according to our practical experience, that's going to fail. The thing gonna collapse.
Yeah, so you see the blue part is the one that shows the maximum displacement.
Nowadays, if we look at the construction site in Singapore, you can see many low-skilled labor workers. One major task is we try to reduce the dependency of the foreign labor in Singapore by using automatic robotic construction. We started investigating concrete printing since 2014, and it's still quite new in the industry. So traditionally, you have to use a 3D model, right? So we can directly to translate this 3D data into the construction site and just build it. I think that is the game changer, because the robot is actually quite patient. Robot is very accurate, very precise.
This is a 3D printed bathroom. It's the most complicated part in an apartment. 3D printing of bathroom is faster because you can do it off-site and it's fully automated and doesn't slow down the other building works around the apartment, and you can just slot it in modularly. 3D printing actually emanated from rapid prototyping well over 30-40 years ago. It's digitalizing designs and then using machines to follow a print path to make a product. It's very precise. Every design can be customized. You don't have to have the same shape, same dimensions. Every print can be different. You can call it mass customization. .3D printing in construction industry probably started around the same time we started as well. The first 3D printing experience I had was trying to work with cementitious materials. It's a bit far-fetched initially because concrete is actually hard to mold and form. So we started from basically square one, trying to learn how concrete behaves, what sort of machines can work with concrete, and actually get quite good prints from there. We want to be trailblazers. We want to work with new materials, ideally sustainable materials. This is a stool printed from bottom ash material. So it's demolition glass that we ground down to like a sand-like particle, and we printed it. So for every new material that we use, we have to study how it flows, how it strengthens, and how buildable, how many layers you can build on top of it, and how fast you can print.
The concept of NEWSand was developed in Singapore. It means that we convert either ashes or waste byproducts into sand replacers.
We also try to perfect our different mix by adjusting the water content and the super plasticizer for these.
So this is an example of municipal solid waste that every one of us generates in our households. We are able to convert them to sand-like material, and that makes possible to replace the sand in the application in construction. This technology utilizes a furnace at high temperature and gasifies the waste, producing syngas. And the ashes are being converted or melted, then forming the slag. Sand is one of the major components that is used in concrete.
These are two different design mix that we do for our NEWSand concrete. When we add 2 liter amount of the SP, then there is not enough workability. Then there will be air voids and gaps.
For that reason, we reach out to Prof. Tan, who is a specialist in 3D printing technology, to explore advanced applications of NEWSand in 3D printed concrete.
One of the downsides of waste is that it has to go to landfills, and some of these landfills are not suitable for vegetation, and Semakau is going to be filled up very soon. So if you can repurpose some of these waste to make them useful products, I think that would be a win-win solution for all.
So what sort of material final product are you thinking making it out of the NEWSand?
Maybe we can try to print bathtub.
Okay.
So that we can actually test its water permeability of the material, whether there's any water leakage.
Yeah, okay.
We do have to change its composition to make sure everything flows well, doesn't have any breakage during printing, and it will have substantial buildability. Of course, there will be difficulty, but we'll have to try.
HDB has ventured into 3D printing a few years ago. Our research currently is focused on low-rise structures and is mainly experimental, but in future we also will look into 3D printing for high-rise construction. So we are looking into building complex shape elements, and we also want to give the architects flexibility in their design, so they are not constrained by precast methodology. So that's why we are looking into 3D concrete printing.
The total duration of the printing time is about 13 hours. So we have the one facade element over here. Using 3D printing, you don't need to use any foam anymore. You can directly to print it. See over here, now we are printing the skin. So in a way, we are printing a permanent foam work. Because conventionally, we have like foam work, we cast concrete. Once the concrete is hardened, we remove the foam work. So that's not smart. The concrete printing research project, we're also trying to experiment something related to the architecture element, that we can explore the different design possibility in this case. We are trying to do the prototyping and research by trying to make use of concrete printing object.
We anticipate that we can showcase such landscape architectural elements maybe in about 1 or 2 years' time down the road.
If you talk about the manufacturing industry, the agriculture industry, even banking and information technology, they have gone through their revolutions. But the building and construction is still stuck in the Stone Ages, where you need a lot of workers on site. There are work site safety issues, there are elements of the weather. Right now we're printing a baby bathtub. We find this design very useful to gather a lot of information. We want to make sure that it attains the strength of normal concrete to meet standards for adoptions.
Initially, when we tried to print with NEWSand, there's a lot of clogging and jamming up the holes. For the first print, it's not able to sustain the subsequent layers. That's why it tends to slump at the bottom layer and fails. So what happened is we have to do a lot of sieving to make sure that we get the correct size, the correct gradation.
This is a test piece here. It has similar printing parameters as the bathtub. We're going to load it on the test jig. This is a 3-point bend test. We're going to increase the load at the midpoint until it breaks. We are always hopeful that it will meet the required strength. And if it doesn't, we have to go back to look at the mix and see if there's anything we can optimize to get better strength.
Maybe during printing, we already can do some kind of surface finishing.
Currently, we noted that some challenges during 3D printing is that if you were to print too quickly, then the layers will buckle and collapse.
True.
Then if you print too slowly, the layers will harden, delaminate as well.
True.
So I think we have come up with a software to check on the printable design to prevent the premature collapse. HDB's robotic gantry printer is the largest in Southeast Asia, and we are able to print life-size volumetric components up to a length of 9 meters long, width of 3.5 meters, and up to a height of 3.8 meters.
Today we are actually trying to change this L-shaped column to rectangular column. So the cross-section of each layer is much shorter, and we're also trying to use a different material and with a different water content to see can we control the printing process and also to control the material consistency. And today we also notice the temperature is higher, the humidity is higher. And when we do concrete printing, all these environmental factors has a huge impact in the entire process. So we do hope that in the future, we need to have another system to control this variable to give a consistent property in the long printing process. So the current concrete printing research project, we know that we can print concrete here in Singapore. We can control the material quality, we can scale up, we can print a big object, big wall, big column. But the next phase is really about structural application. How can we make use of concrete printing in the public space?
So we're looking at a water seepage, or they call it water ponding test. We're going to fill this bathtub with water and look for signs of seepages of water. If there's water seepage, means the filaments are not bonding well enough. So there are gaps in there, water can come up. So not perfect, but it's leaking out.
You can change probably to add a bit more layers on the sides to change the design a bit.
Thicken the side.
Yeah, so that it's strengthened on the side. and also change the mixture composition.
Still, you can improve, right? A bit low at the strength.
We are still in the research and development, but we already can see concrete printing structure being used in Europe, in USA. Some people, they may have concerns saying that if you're doing layer by layer, then you might have certain delamination in the structure that might compromise the concrete structure. When you have a new technology, when you have a new material, you have a series of structural testing methods. For example, you have compression test, flexural bending test, you want to test the shear force, you want to test the shrinkage, you want to test the moisture loss. So that's why we have NTU on board, because they can do all these civil engineering and structural calculation and structural test in their testing lab.
We did a material test, and we want to understand material properties of the concrete printing structure.
In terms of the 3D printed shells that we have just seen downstairs, you will find that there is no reinforcement between the layers of the 3D printed concrete. We need to improve the bonding between the cast-in concrete and the thick shell if we want to also utilize the outer shell as part of the dimensions for the concrete column.
The resistance of the specimen we have tested is quite high, so I think 3D printed concrete walls is a very promising application of 3D printing concrete.
A lot of time when we talk about 3D concrete printing, we are not here to say we want to take over or to replace the entire conventional construction method. So we are actually trying to create this ecosystem. We know that we can't do everything by ourselves. We need university, academia, industry, contractor, governmental agency, everyone come into play.
I'm currently changing the design of the printer so that it doesn't have so much tilt on the bathtub. When we have lesser tilt, it means the design is more stable. What I can do is I can reduce the speed on the first few layers.
When we print, especially if there's not enough pressure or when there's not enough addition between the layers, porosity will be like gaps that are formed. Now we are doing another run, and the main thing is we notice the corners and the curves. We need to deposit more material on the outside. As the printer moves, right, if it changes direction, you need to make sure that it's depositing the same amount of material.
We're able to prove that the printed part is able to have a good buildability. There isn't leakage between the filaments. So to find out whether test pass or fail, if there's water retention in the wall, the specimen will actually be heavier than the specimen that's not being tested. So with the new composition of our material, the specimen that we've tested has passed the test. It's the first print, and then for the second print, we reduced the print speed, but then it somehow still slumped a bit and caused water to leak at the side of the bathtub.
I see, so the speed of printing actually defines also the thickness of the concrete.
Working with different materials adds to our library of knowledge, what we must do to make them printable, usable, and more durable.
With the research that we conduct together with Dr. Tan, we wish to achieve an optimized composition of concrete that is 3D printable. The 3D printed bathtub is evidence that NEWSand can be used in 3D printed concrete, and that would allow us to go for various applications in 3D printing and ultimately in everyday life. We could print all the items that typically are made of concrete. So what else can we print?
Actually, we can try something larger.
Shelters.
Shelters.
I foresee in the immediate future a hybrid construction process where smaller parts are 3D printed and in modules and slotted into buildings. This project actually excites me because it's a chance to change the world, change the industry, make it better, safer, probably save the earth using more friendly materials in the construction industry.